Hi, everyone. When I wrote my notes earlier for class, I neglected to share my screen, and so I'm having to make this video again, but that's fine. I'm not going to write them all again. I'll just talk through the notes. This is Math 60 video lecture for section 1.4 and 1.5. Section 1.4 is all about the order of operations, which is our mathematical grammar. Just like we use grammar and punctuation and other rules to organize language, we use order of operations to organize our mathematics. So if you've never seen this acronym before, PEMDAS, this is our order of operations acronym, and it stands for parentheses, exponent, multiplication, division, addition, and subtraction. This is our basic order of operations, but there are exceptions, and I'm going to spend a fair amount of time talking about what the exceptions are. Because other than the exceptions, it's pretty straightforward. You do things in a parentheses first, then you take care of any exponent, arithmetic, then you take care of multiplication and division, and then addition and subtraction. So before we get to PEMDAS, in general, actually, sorry, this is parentheses, so it's right when we get to PEMDAS. In general, if you have a list of mathematical operations and there are parentheses, do what is in the parentheses first. And I have two examples. I have 7 minus 5 plus 4. If there are no parentheses, I work left to right. So first I do 7 minus 5, which is 2, and then I add 4, and I get 6. If there are parentheses, 7 minus the quantity, 5 plus 4, I do what's in the parentheses first. 5 plus 4 is 9. And then I do 7 minus 9. And so you can see that these give me different answers. Parentheses are very important. They are the primary way that we signal the order of mathematical operations. However, there are a number of exceptions or subtleties for parentheses. The first exception is that parentheses can be redundant, but still helpful. So if I have 7 minus 5 in parentheses, then plus 4, I didn't really need these parentheses. I could have just gone left to right, but they help me be sure that I'm going to do the 7 minus 5 first and then add 4. So they're redundant, but they're still helpful. And I encourage you to use parentheses to signal what you're going to do first. All right, second exception for parentheses in particular. Sometimes parentheses are not written, but they are implied. And this happens most often with division. So for example, if I write the mathematical expression 7 plus 5 over 3, well, I can see I have an addition and I have a division. PEMDAS would tell me to do the division first before the addition. But a fraction or a division that takes the fraction form, it has an implied parentheses for the top. So you actually are going to do the 7 plus 5 first, and you get 12 over 3, which is 4. It does work if you do it the other way, but you have to be really careful. If all you do is divide 7 by 3 and you ignore the 5, you're not following the right mathematical operations. So if you're going to do the division first, you have to divide each of those terms by a 3, and you get 7/3 plus 5/3, which we can do, but that's more work. So in general, if you have a fractional division, there's an implied parentheses on the top and maybe on the bottom that you do before you do the division. There are a couple other examples of that where they're not written, but they're implied. But most of the time, you're going to see it with division. And the third exception is that sometimes parentheses don't look like parentheses. The square root symbol acts like a parentheses. So does the absolute value symbol. If I put something in the middle, 3 minus 2, this acts like parentheses. Even though it's not a parentheses symbol, it's going to happen first. So as an example of that, square root of 10 plus 6, you do the 10 plus 6 first. So you get square root of 16, which is 4. And in the book, this is called other grouping symbols. Another one you might see is this bracket, which is often used, for example, down here when you have nested or two levels of parentheses. Going back to our implied but not visible, 3 raised to the 2 plus 5. Even though we don't see the parentheses there, that's in the exponent. And so we do the exponent arithmetic first, 3 to the 7, which is 2187. Okay. I know that I'm going a little bit faster through this because I don't have to write, but you can always pause and reverse the video if you want to see something again, and there will be captions if it helps to see my words that I speak, if it helps to see them written out. So another example that you need to keep in mind are nested parentheses, where you have an inner parentheses and another level in outer parentheses. And when you see this, you do the inner parentheses first. 7 minus 5 inside parentheses becomes 2. Then we add 3 outside parentheses to get 5. 5 divided by 6 gives me 5 over 6. All right, that is how parentheses factor into the order of operations. Exponents come after parentheses. So if I see something like 2 to the 4th minus 7, I do the 2 to the 4th first, which equals 16. And then I subtract 7 and I get 9. Here I have an exponent, but also a parentheses. So in this case, parentheses comes first. 2 plus 3 equals 5. And then I do the 5 plus 1. So I end up with 5 to the 5 plus 1, which is 5 to the 6th. And then I add 7. 5 to the 6th. I grab my calculator. I don't know that number by heart. 15,625 plus 7 equals 15,632. If you have exponents inside exponents, you just do the inner exponent first. 3 squared to the 4th. 3 squared is 9. And 9 to the 4th is 6,561. That takes care of the exponents. Moving on to multiplication and division. Multiplication and division are interchangeable in terms of order. So you don't always do multiplication before division. If you have things just written one after the other, you still have to do left to right when it's all multiplication and division. So to me, this is one of the bigger issues, is that we write PEMDAS, but really the M and the D, they're interchangeable. They're equivalent operations. So my example, 10 times 5 divided by 2. If I don't have any parentheses, I do left to right. So I'll do the multiplication first. 50 divided by 2, which is 25. But if I have an expression where I have 16 divided by 4 times 9, again, because there are no parentheses, I'm going to work left to right because division and multiplication are the same type of operation. 16 divided by 4 is 4, and then multiply by 9, and I get 36. Now, I think this can be confusing, and the best way to get around this is to not use this inline division symbol, but to write your divisions as fractions. 16 divided by 4, I can write as 16 over 4, 16 divided by 4. And so when I do 16 divided by 4 times 9, well, I could do the 16 divided by 4 first, which is 4, and then multiply by the 9 to get 36. Or I could do the 16 times 9 first, which gives me 144. 144 divided by 4 is also 36. So write division as a fraction. That is my recommendation to you. If you want to keep track of order operations, once you write it as a fraction, we don't have to worry about the order of operations so much with division and multiplication. I can also think of division. Division can always be written as multiplication. 16 divided by 4 times 9, I can write as 16 times 1/4, because that 4 is in the denominator, it's in the bottom, times 9. And now all of a sudden I all have multiplication, so it makes a lot of sense just to work left to right. This actually is a really useful way to think about it. Think about division as multiplication, because sometimes we end up with repeated division. And I will write this again so you can see what it looks like. If I take 36 divided by 2, and then I divide the whole thing by 3, well, I could write that as all of this divided by 3 could be all of that times 1/3. And now I don't have two levels of division to carry around. I have a multiplication by a fraction times that other division. And when you multiply fractions, you just multiply the numerators and you multiply the denominators, and you get 36 over 6. That divide by 2, divide again by 3 becomes divide by 2 times 3, or divide by 6. This takes practice, and that's okay. You'll have chances to practice and to get some help. But I wanted to point out that division can get messy pretty quickly. So if you can write division as multiplication by a fraction, you've gone a long way to simplifying your work. Okay? Moving now to addition and subtraction. This suffers from the same issue that multiplication and division have. If you don't have parentheses, you might end up doing your subtraction first. So you can't think of addition always comes before subtraction. It's just that either of these come after everything else. As an example, if I have 10 minus 7 plus 3, well, no parentheses means I work left to right. So 10 minus 7, I'm doing the subtraction first. And then I add 3 to get 6. A workaround is do all of the additions before you do any of the subtractions, but you have to combine all the additions. All right, so we learned in an earlier class that it's called the commutative property. 10 minus 7 plus 3, I can write as 10 plus 3 minus 7. And once I do it in that order, then I can do the 10 plus 3 first, which is 13, minus 7, and I get 6 in both cases. So the key here is addition and subtraction. One does not win out over the other. You just work left to right. So this is an example where parentheses that are redundant but helpful would come into good use. Let me put parentheses around the 10 minus 7 just to remind me that I'm going to do that first. And all of a sudden, I don't have to worry about left to right, addition, subtraction. Instead, I get to use the parentheses step. Okay. Often we work with numbers that are big enough that we want calculators to help us. Some calculators are really good at following orders of operations, others are not so good. So my strong recommendation is anytime you have to do a long chain of arithmetic in a calculator, is do one step at a time and record the intermediate numbers. Record what you get every step. So here I have 5 plus 2 inside parentheses raised to the 9th minus 3 divided by 18. PEMDAS would tell me to do the 5 plus 2 first. And so I do that and I record the answer. So if I were to use a calculator, the only thing I would do with my calculator is 5 plus 2. And then I would write that in my new expression. That's my only parentheses, so I'm done with that. Now I have an exponent. So I take just the exponent part into my calculator, and I do 7 to the 9th, which is this really giant number, 40,353,607, and I record that answer, and then I have a minus 3 divided by 18 is still there. That took care of my exponentials. I don't have any multiplication, but now I do have a division. So I do just the division, and I do 3 divided by 18, which gives me 0.1667. And I record that step. So now I have 40,353,607 minus 0.1667. There's no addition, so now I'll do the subtraction, and I end up with this final answer. 40,353,606.8333 repeating. I generally don't trust a calculator to do all of this in one step correctly. If you are going to do that, you need to make sure you use the parentheses as part of your calculation. But in general, I do one step at a time. I recommend you do the same. One more example from section 1.4. It just has negatives and positives, minus and plus, minus and plus. And this example is really using parentheses to help. Rather than try to figure out what I do first, I say, well, they're all minus and plus, so I'm going to work left to right. So I'll just put some parentheses around the 30 minus 9 to remind myself I'm going to do that first. And the result is 21. And then I write the rest of it, and then I'm going to do the 21 plus 2 next. So I put parentheses around that, and that equals 23. Minus 6 plus 18, I'm going to do the minus 6 next. 23 minus 6 is 17. And finally, I add 18 to get 35. Parentheses are super useful as you're doing your arithmetic in multiple steps. It'd probably be a really good idea just to remind myself is to put parentheses around the 3 divided by 18. So I remember to do that before I subtract the 3. All right, that covers section 1.4. The best thing you can do is practice, practice, practice. Get a lot of questions. The textbook itself has questions. All of the, hold on, I'm going to grab the textbook. Here we've got a bunch of questions. These ones involve all sorts of different operations here. Every odd question, if you flip to the back of the book, every odd question has an answer. It doesn't show you any of the work, but it does have an answer so you can check your work. So for example, section 1.4, question 49. I can go to section 1.4, question 49. That was not a good one, so I'm going to pick a different one. Let's do question 47. Section 1.4, question 47, 3 to the 4 minus 3. And the answer is 3 right there. So you can check your work. Your homework questions on My Open Math will have a lot of these. If you don't get it right on your first couple tries, you can do a new version of the question. Just keep working on these until it starts to come naturally. And if you need additional support, that's what tutoring and myself are for. Okay, section 1.5, we return to solving equations. This time we have multiplication and division. Section 1.3 was solving equations with addition and subtraction. And now we have it with multiplication and division. An example, 3x equals 90. If I were to say this in words, I would say 3 times a number equals 90. If we solve this equation for x, we are saying, what is that number? 3 times a number equals 90. What is that number? I had a student in class tell me, well, x equals 30 because she knew that 3 times 30 equals 90. She used a numerical representation. She made a guess, 30, and she checked it. 3 times 30 equals 90. That all made sense, so she knew she was right. If you were to do this question symbolically, you might start with 3x equals 90 here, and then to undo multiplication, we use division. So we would divide both the left and the right side by 3. That's how I get this part here. 3 divided by 3 cancels and becomes 1. So we get x equals 90 over 3, or x equals 30. We undo multiplication by using division. Another example, y divided by 4 equals 9. A number divided by 4 equals 9. If we solve for y, we are asking what is that number? So if I were to do this by hand, and I start with y divided by 4 equals 9, and sometimes we say y over 4 equals 9, to undo division, I use multiplication. So I'm going to multiply both sides by the division by the 4, and those 4 over 4 cancel, and it leaves me with y equals 9 times 4, so y equals 36. That's section 1.5. There's hardly anything in the textbook for explaining it. It just shows an example of solving with multiplication, an example of solving a division equation, and then it has lots of practice problems. So work through that homework to practice solving equations with multiplication and division. And finally, in the lecture, I talked about fact families. And here I'm going to talk about fact families with multiplication and division. So if I start with 5x equals 65, I can build each of these other fact families by doing various mathematical operations. If I divide both sides by 5, that's what I'm doing here, I get x equals 65 over 5, which actually can simplify into x equals 13 if I want. This one here, I divide both sides by x. I can do that, and then instead of 5x equals 65, I have 5 equals 65 over x. I can go one step farther and now divide both sides by 65, and I get 5 over 65 equals 1 over x. So we can build a lot of equations that are all equally true, and these are what are called fact family equations. But one thing I want to point out to you is usually we are trying to solve 5x equals 65, and most of these equations are not super helpful. This one, 5 equals 65 over x, isn't helpful because x is in the denominator, and same here. And this one, isn't so helpful because x is divided by a number. So fact families can get us to a lot of different equations, but usually there's one way to go that will actually be useful for finding the x value that makes the original equation true. All right, that concludes our video. The notes will be posted as well. Thanks for watching.